Hi all. Let's use a Python notebook to take a look at the data surrounding South Africa's COVID-19 lockdown. What you see in front of you here is a Jupyter notebook hosted by Google on their site colab.research.google.com. You can create your own free Jupyter notebook there if you have a Google account. In this particular Jupyter notebook, we will be using a couple of Python tools. We'll be using NumPy, we'll be using Pandas, Matplotlib, and a stats package from SciPy. The NumPy is just a mathematics package. Pandas allows us to use tables that look a little bit like Excel spreadsheets in a way, and then Matplotlib allows us to plot it. And I'll show you later what we're going to do with the stats. First, we need to load the data. This data is available on GitHub, and if you read the code on this notebook, which I will share in the link, you can see where we're getting that from. So we read the data into a Pandas data frame, which is, as I say, rather like using a spreadsheet. And here you can see this is what the data actually looks like that we've loaded. Now, plotting the data with a Matplotlib, this is what we can see. So first a quite steep exponential growth, then from the 27th of March onwards a slightly less steep exponential growth. However, we're much more interested in seeing this is the cumulative number of cases, reported cases in South Africa. I want to see how many new cases were reported each day. So what I do is I take the new cases as being the confirmed cases, or the total confirmed cases, with this function called diff. So that just takes the day before's data and subtracts it from the current data, and that gives us the new cases per day, and then we plot that as a bar chart. And so this is what the new cases per day looks like. Now, what we really want to know is, when did these cases actually become infected? So on a particular day, a certain number of new cases are reported. This is after they've been tested and positive test results have come back. So if on a particular day it says that 100 people were reported as being COVID positive, that is not when they actually caught the disease, but a few days later. In fact, it turns out that because it takes about 5 days for the symptoms to appear and another couple of days for the test results to be available, the infection actually took place at least 7 to 10 days before that. So I'm going to shift the data around using a normal distribution. A normal distribution looking like this. So where if a certain number of cases were reported on what is day 16, the numbers at the bottom are days. So if they're reported on day 16, I'm actually going to distribute them back such that 12% were on day 8 and 2% were on day 0, etc. So we're shifting and spreading those results among the previous days based on the idea that they were most likely to be between 5 and 10 days ago. Alright, 7 and 10 days ago. Let's scroll down a little bit further. So what I'm doing is I'm going through each day and replacing that day's number with that normal distribution shifted back, as we can see. So that's what that looks like. We then go and plot the sum of all of those normal distributions added up together on the same graph as the original daily reported cases. And there's a couple of points of interest. You can see it's smoother and slightly spread out, starts a little bit earlier. One point of interest is that this tailing off data at the end here is meaningless, because that's assuming that after the last day here we actually had 0 cases, which isn't going to be true. We don't know what's going to happen after the current date. So what I'm going to do is I'm actually going to cut that off, and then I'm going to add a couple of key dates. I'm going to add the date at which South Africa closed its ports, and I'm going to add the date at which South Africa went into full lockdown. So those dates are, in fact, the 18th of March and the 27th of March. And this is what our new graph looks like. So as you can see, the infections were increasing quite rapidly up until the day the ports were closed, and then it decreased equally rapidly, and surprisingly, at the point of the lockdown, we start to see a big increase. And if we look at the calculation on the spread rate starts off at about 1.3. So that means that South Africa's number of cases was doubling every 3 days, which was quite normal for COVID infections. It was dropping even before we closed the ports, but dropped dramatically after the port closures, and then rose up again to about 1.05, and has remained fairly close to that figure throughout the lockdown. And that's what these calculations are all about. As I say, if you want to see the actual Python code of how we did it, I have attached the location of this Colab file in the description.